Okay, so the steps to solve variation problems. And I like these problems. They're very straightforward, and there's usually just kind of the same 4 steps. First, you have to identify the model. So is it a direct variation? Is it an indirect variation, or inversely proportional to, or inverse variation? And they'll have to tell you that. We haven't talked about joint variation, but that's going to come in a minute. So you identify the model. Then they have to give you enough information to find K. Or tell you what K is. But usually they want you to find K. So you do some research. You say, okay, well, here's my model. If you out in the real world, you find this model and you say, okay, I need to find the constant of proportionality. So I find some data, a point in time. If it's our lemonade problem, oh, we sold 1,000 glasses of lemonade when it was 100 degrees. Anyway, then we can figure out the constant of proportionality. And then we can set up the formula. So you write the formula with K. And then finally you're going to answer the question. They're going to give you a new situation and they're going to want you to solve. So back to our example, if we sold 1,000 glasses of lemonade, I'll say glasses, cups of lemonade, when it was 100 degrees out, and we figure out what K is, then we could say a question like, well, how many glasses or cups are we going to sell if it's 110 degrees, that type of thing. And so you can figure those things out. So those are the steps. There's 4 steps, and that's how it works. We'll show you an example now. This is an inversely proportional, or varies inversely. We haven't done an example of that, but if you notice, it's the exact same example, except they changed like one word. It's not direct variation, but varies inversely. Okay, so we'll show you how to do that. It says the quantity y varies inversely with the cube of x. So y is equal to k over x cubed. That's the inverse variation right there. The x cubed is in the denominator. Okay. Then they say, well, if y is 25 when x is 2. So they give us a point in time. We know a y and x, an input and an output. That allows us to find k. So we're going to plug in 25 for y and 2 for x. This allows us to find k. So multiply both sides by 8. And what's 8 times 25? 200, 200. Okay, so you get k equals 200. Now you're going to take that k, and I've scrolled too far. Oh, no, I didn't. There's my formula right there. So, or my model. Now I'm going to write the formula y equals 200 divided by x cubed. Now this then is a formula that I can use. I can say, hey, give me an x value, I'll tell you the y, or the other way around. Give me a y value and I can figure out what x is. Okay, so the question they ask, I don't really have to scroll up, but I will. It says find y when x is 6. Okay, so we have our formula. Now we can find what y is when x is 6. So we get y equals 200 over 6 cubed, which in our last problem, 6 cubed was 216. Now, they might want this as a decimal, or they might want it as a fraction. If I divide by 4, I get 50. How many times does 4 go into 216? 216 divided by 4. 54 times. Oh, I guess I could have divided by 8. My bad. So 25 over 27. There it is as a fraction. If you want it as a decimal, it's going to be some repeating decimal. I'm going to get approximately 0.926. Sometimes they'll tell you, oh, round to the nearest, hundredth or thousandth or something like that. But that's what it is. So if they want a fraction, great, that's an exact answer. This is rounded off, decimal. So in the real world, a lot of times they'll just go with some rounding off, like on the BMI problem, they rounded to like 1 decimal place. But you know, the more decimal places you go, the more accurate it is. Anyway, they might just want the fraction here. So.